So let's look at this question, the definite integral from b to 2b of x to the fifth dx. Just like before, we have our two-step process. We're going to find the antiderivative, and in this case it's straightforward because it's power rule for antiderivatives. So when we find the power rule, we identify what is our power, and then as long as that power is not equal to -1, we're going to be looking at 1 over n plus 1 times x to the n plus 1. So we end up with 1 over 6 x to the 6th. The second step, and we always call this function that we usually call it big F of x. You can call it something else, but big F of x is standard. After we do that, now we're going to be looking at f of 2b minus f of b. I'm going to resist any jokes I could make about 2b or not 2b. Let's just evaluate this. So all we have to do here is do 1/6 2b to the 6th minus 1b, or 1 over 6 times b to the 6th. This is my final answer, and it's totally okay if there are b's in your final answer. And in fact, there's no way around it. You can't just like plug in a number for b. You were asked to solve this in terms of an arbitrary b value. I think it's kind of cruel that they used b and that we wound up with 6, because b and 6 can look kind of similar. So I hope that's not confusing any of you, but this is the process. You find the antiderivative, and then you plug in and you evaluate and subtract. The fact that there are b's instead of numbers doesn't really cause any difficulty. I think this question is also getting at the fact that typically we write this as the integral from a to b of f of x dx, and that maybe they're trying to get you to where you're flexible enough to look at the different letters in different contexts. But that's how you do this problem. Find the antiderivative, plug in and subtract. It's just that you'll end up with symbols in your answer instead of numbers.